All right, welcome to our video on permutations with distinguishable objects. This video is part 1. In this video, we're going to learn to calculate the number of possible permutations with distinguishable objects. In this video in particular, we will look at how to order just a few of our total possible objects. We are going to use two different strategies to solve these problems. The first will be to use an equation, and our second strategy will be to leverage technology to help us solve the more complex problems. So far, we have learned to calculate the number of possible permutations when we order all of the distinguishable objects that are available to us. So for example, we have calculated the number of permutations when a class of students line up for their photo. In this scenario, all of the students are lined up and each of the students are distinguishable from one another. Now in this lesson, we're going to take this one step further and we're going to take a look at how to calculate the permutations possible when we're only ordering a few of those distinguishable objects instead of all of them. So for example, perhaps I would like to calculate the number of ways that I could order the top 3 swimmers in a race that has 8 total swimmers competing. In our examples today, we're going to learn to use this equation. Now, this I read as NPR, where N stands for the total number of distinguishable objects, and R is the number of objects that I'm going to select for the permutation. So this is n factorial divided by the difference between n and r factorial. Now, as we dig further into this equation when we go through our examples, it's going to be important to take a look for connections back to our work with the fundamental counting principle. I think you'll see quite a few of them. Let's dig into our first example. It says, Matt has downloaded 10 new songs from an online music store, and he wants to create a playlist using 6 of those songs, and they can be arranged in any order. Now, the question says, how many different 6-song playlists can be created from these new downloaded songs? In this question, we're asked to order or make a playlist of 6 songs out of an available 10 possible songs. So our n value will be equal to 10, and our value for r will be equal to 6. 10 is the total number of possible songs, and 6 is the number that we're selecting. All right, so in this question, this is a pretty straightforward question with quite small values. So we're going to use this equation to help us solve the problem. We're going to link our understanding of factorial notation and the fundamental counting principle as we go here. So let's start by writing out our equation. NPR equals n factorial divided by the difference between n and r factorial. So I'm going to start by plugging in what we know. So we know that our value for n is 10, so it's 10p6. I can think of that as saying I'm going to pick 6 songs out of 10. On the top of our equation, I'm going to have 10 factorial divided by 10 subtract 6 factorial. Now it's important that we keep those brackets around that subtraction statement. Now, if we simplify this a little bit further, we'd have 10 pick 6 equals 10 factorial divided by 4 factorial. Now I'm going to take my understanding of factorial notation and simplifying these types of equations. So I'm going to start out by writing a few factors on my numerator, and I'm going to stop when I get to 4 factorial. I'm stopping here because I can see that I'm going to be able to cancel out the 4 factorial on the denominator. So once we've finished our cancellation, we're left with a simple multiplication statement, and then we can evaluate. So in this case, if I want to pick 6 out of 10 possible songs to make different ordered playlists, I would have 151,200 possible playlists available to me. Next up, we're going to take a look at an example that's got much larger numbers. So we're going to be able to take advantage of the technology that we have available to us to solve this problem. Let's start by reading it through. So it says Tanya needs to create a password for a social networking website she's registered with. The password can use any digits from 0 to 9 and or any letters of the alphabet. It says the password is case sensitive, so she can use both lower and uppercase letters. A password must be at least 5 characters to a maximum of 7 characters. And each character can only be used once in the password. So the question's asking us, how many different passwords are possible? Let's start by determining the total number of possible characters that Tanya can choose from to create her password. So it says that we can use any digits from 0 to 9, so that's 10 possible digits. And then we've got 26 letters in the alphabet. Now, it also says that we can use both upper and lowercase letters. Those are distinguishable to the social networking website. So we can use 26 lowercase letters and 26 uppercase letters. That gives us a possibility of 62 characters to choose from. That means that our n value is going to be equal to 62. All right, let's dig into these passwords. There are a few different cases here because it tells us that we can have a 5-character password at minimum up to a maximum of a 7-character password. So that means we've got a few different scenarios here, or we call these cases. We could have a 5-character password, that's the minimum, or we could have a 6-character password, or we could have the maximum 7-character password. Now, when I'm analyzing problems and I'm trying to determine, okay, are there a number of cases here, or is there just one scenario like the playlist example we just finished? I look for keywords like at least, at most, a minimum of, or in this case, I see the phrases at least and the phrase to a maximum. Those indicate to me that I've got multiple different scenarios here that I'm going to need to consider. Let's break this problem down into each of the cases. Let's start with case number 1. So we have 62 possible characters to choose from. And in case number 1, I would have a 5-character password. So this would be like saying 62 pick 5 for my password. Or case 2 would be having a 6-character password. So in this case, I would still have 62 possible characters to choose from, but this time I'm going to pick 6 of them to order. Or I could have case 3, which is the maximum number of characters. So again, in this scenario, I've got 62 possible characters to choose from, and I'm going to pick 7 of them to order. Now, if we think back to our work with the fundamental counting principle, we know that when we see that keyword or, we have to add up all of the different scenarios. So I'm going to figure out the total number of permutations for case 1, case 2, and case 3, and then I'm going to add them up at the end. Now, if I was to use the equation that we used in example number 1 to evaluate each of these cases, you can see that I would have a lot of simplifying and evaluating to do, and our numbers would get really big. If I have 62 factorial, that's a big number. So instead, we're going to use our scientific calculator to help us out here. Our calculators have this permutation function in it, and we can use it to evaluate these expressions. So in my calculator, I would type 62p5. Now I'd like you to pause here and make sure that you can figure out how to use your calculator with the permutation function. Don't forget that you can use the Desmos calculator available online if you'd like to. All right, so let's calculate each of them. So the first one is 62p5. So I use my scientific calculator and I end up with this really big number. 776,520,240. You can see that would have been a little bit cumbersome to do in our equation. The next scenario, where we have 6-character passwords, we get 4.426, etc., times 10 to the power of 10. That's written in scientific notation. That's a really large number. And then case 3 with the 7-character password, you can imagine there's even more possible permutations. So this one is 2.478, etc., times 10 to the power of 12. So our job here is to add up each of these scenarios to figure out the total number of possible passwords. You can see here that the final number is a really, really large number. I've written it in 2 different ways, out in its full standard notation, and then I've written it in scientific notation. That's 2.5 trillion possible passwords. Let's summarize what we've learned in this video. Our goal was to learn to calculate the number of permutations when ordering only a few of the distinguishable objects that were available to us. In the scenarios where the numbers were small and we had a simple case, we could make use of our permutation equation. When the scenario is more complicated and the numbers are much larger, we can make use of technology to help us evaluate and make the process simpler. When analyzing problems, it's important to determine whether or not there's more than one case involved. When we see phrases such as at least, at most, or minimum maximum, then there's likely more than one case to analyze.